Hi, Michael. How are you today?
Very well, Danielle. How are you doing?
I'm good. I've had a really nice day, and it's going to get even better now that we're starting this webinar. So,
Fantastic.
hello, everyone, and thank you for joining us today. My name's Danielle Walmsley. I'm Business Development Manager here at Element. I'm supported here today, or I'm supporting today, rather. I'm supporting Michael Darby, our Technical Director, and we are doing a webinar today, which is part 2 of a 2-part webinar series on the topic of using radio modules for connected devices. This webinar describes the integration of radio modules into other equipment, the testing and the regulatory approvals required for placing the equipment on the market in North America and in Europe. This is important information for anyone planning to use radio modules on their products and useful for the radio module manufacturers too. As I mentioned, our speaker is Michael Darby, here with me today. He's Technical Director here at Element for our global team of connected technology laboratories and certification bodies. Michael has been in the engineering and compliance industry for more than 36 years. He started his career with a manufacturer, getting their own products through EMC approvals. He then worked for commercial test labs in the fields of EMC and radio performance. He then moved into regulatory approvals, becoming a TCB and notified body. He supports Elements labs and customers from his office in the UK. Michael is a member of the TCB Council Board of Directors, the chairman of the Modular Committee who advises the FCC on radio module policies, and the author of the European Guidance on Radio Modules for the Radio Equipment Directive. And we're now passing over to Michael. Thank you, Michael.
Thank you very much, Danielle. I will now share my slides. Okay, so hello everybody and welcome to the webinar. This is part 2 of the radio module webinar series in October 2023. So yet again, there's me, your speaker for today, Technical Director at Element Materials in our Connected Technology Group. I am an engineer, but not only am I keeping maths and equations and standards out, but I really have genuinely done some colourful drawing. I'm actually not a bad artist, but I've really gone basic in my kiddie crayon drawings today. They look pretty bad, but the whole point is to try and make them look simple and hopefully a bit of fun. So my whole point really is about trying to solve the problems that we're trying to solve and communicate that to you in a way that hopefully is easy to understand. I could sit here and recite standards to you, but I really don't think that message is getting through. So the goals for today then are to review the North American and European requirements when you install a radio module into your product. Why are we even doing this? What's the point? We're going to look at the authorization of the final product and what testing you need to do. And then we'll hopefully have a quick summary at the end, and we will have time for questions and answers. So as with last week, where we talked about the radio module itself, we're focusing here on the USA, Canada, and Europe. And with Europe comes Great Britain. It's all about trade. It's all about the regulatory approvals. Now, we did talk about PTCRB and GCF last week as well, but we're focusing really on the regulatory approvals here because it's all about being able to sell your product. Why radio modules? Why the big deal? Why the huge attendance at these webinars? Well, the reality is the Internet of Things, and people want to take their products, which are a cool end product with some really exciting functionality, and they want to connect it. They want to make it wirelessly connected, and therefore they buy in a radio module, put it into their end product, and you have now a radio connected device. So who is the manufacturer of the radio equipment then, and how has that changed over the years? Well, when I first started radio testing, it was pretty obvious who the radio manufacturer was. You know, they manufactured the radio, they knew everything about it, the antenna, the modulation, the transmitter power. They made it, they knew exactly how it worked, and often they looked pretty much like the guy in the picture you see in front of you. Whereas nowadays, that's not so much the case. Reality is, nowadays, the person who gets into all the adventures and has all the responsibility doesn't actually know how the product works. They're the one that all the focus is on, but they don't necessarily know how the product works. And that's typically the person who's using or installing the radio module. So I'm going to get a little bit philosophical actually in this webinar and stray off of the engineering lines. I think in any form of business or any form of strategy, one thing that people forget to do is really understand the problem. Now, what is the problem? The problem is that you want to be able to sell a product which people will want to buy more of, or they'll give such a good review that their friends will want to buy it. In this sustainable circular world, we don't really want to be selling lots and lots of products that break and then we have to sell a new one. What we want to sell is such a good product that if it does have to get replaced, people will come back to you. But better still, they keep your product forever because it works so well and they recommend them to all of their friends. So they must be able to sell it and it must perform well. Now, those two things are linked here. But don't lose sight of that goal. That's what it's all about. And how do you achieve that? Well, actually, all of these regulatory approvals are all based around achieving that. It's very easy to think that innovation is all about getting an exciting product out there and that regulatory approvals are somehow a hurdle or a hindrance to innovation. But the reality is that innovation is supposed to be there to make sure your innovative products get onto the market in a good way. So regulatory and industrial approvals are really there to ensure that the product you sell is a good one. That's the whole point of the approvals. It's not a hurdle or a roadblock to innovation. It's to make sure that those products are good. And of course, from a legal point of view, we know that you can't sell the product if you don't meet the regulatory approvals because they're a legal step. So if you want to meet your end goal of selling a good product and selling lots of them, you've got to pay attention to these regulatory approvals and not carry on thinking of them as some sort of roadblock to you, but instead thinking of them as a good way for you to check your product is a good one. So what kind of product would an engineer make then if there was no regulation? Well, engineers, I'm an engineer, basically we're children stuck in adults' bodies. What would we come up with if we were told to design and make a good product? This looks like a great product. It looks like a lot of fun, but it probably wouldn't pass the automotive regulatory approvals requirements. It looks like a great product, but in reality, the type of product we buy are the ones that pass the regulatory requirements. And it's very easy to think, well, it's not really a great product. It's not very exciting. And in fact, in the picture here, you can see people performing tests. Now, in reality, this is a great product. This is a product that thousands of people all around the world want to buy. It sounds like they're spoiling our fun, but I'm sure if you ever tried to take a corner too fast or stop quickly in that red vehicle there, you'd suddenly realize that the great product is the one that performs well and does the right things. And that actually the one that doesn't meet the regulatory approvals, well, it might have sounded fun, but it really wasn't such a great product after all. So here's a slide I've used before, and I say to people, why do we do these tests? You don't wake up in the morning wanting to do an EMC test. You want to get your product to market as quickly as possible. Similarly, if you know that you have to do a Bluetooth test to see how long Bluetooth hops on each channel, you may not care why it does that or how long it does it for. You just want to get your product to market as quickly as possible. So getting through this is an important thing for you. But those tests aren't just created for fun. And in fact, most of the tests are written and created by other equipment manufacturers who know that their products need to be good, and they're creating just the right test to assess their product in just the right way. And typically not over testing them, but also not under testing them either. Even the limits and levels are carefully planned to make sure the tests are not too onerous, but not so relaxed that we have poor products. So this is another slide I've often used. It's important to remember that testing and approvals are two different topics. They go hand in hand, and we talk about testing and approvals in the same breath or in the same sentence. but there's testing and there's approvals. And you'll see in these slides today that sometimes an approved product may still need some testing. So we looked last week at the main common equipment types, where historically you would have non-radio equipment and you would have radio equipment. And the whole point of radio module installation is that you've got radio connected electronic equipment. So let's start then with the USA and Canada. And as we discussed last week, we've got the FCC and we've got ISED Canada, and they handle all the requirements for testing and authorization of electronic and radio equipment. And the rules are very clear and very well-established procedures, so there should be no ambiguity. But actually, in the topic of radio module integration, this is one of the few cases where there is some choices to be made. So just a quick reminder, we've got unintentional radiators. That's the digital electronics and the radio receivers. And we've got transmitters or intentional radiators, loosely split into the unlicensed and licensed categories. The authorization routes for North America, we've got the Supplier's Declaration of Conformity, or SDOC, which most people would use for the electronics and the receivers. And we've got certification, which applies to most transmitters. There are some digital devices which are exempt from authorization. So, for example, kitchen appliances or parts of vehicle, the electronics of those are exempt from authorization. Also, any receiver below 30 megahertz or above 960 megahertz is exempt from authorization. But those two are separate topics. So if you had a receiver that operates between 30 and 960 megahertz and it goes into a washing machine or a vehicle, it would need authorization. So SDOC, we know from our previous conversations that the authorization route for SDOC is that you must test the correct way, and you must maintain your documentation. For certification, it's very similar. You must test the correct way to the correct standards, keep your documentation up to date, and then the only difference really is that you have to get your homework checked. You have to submit it to a certification body. And we talked about that in quite detail last week, about how you can get the radio module certified such that the certification of that transmitter carries on into the host. So multiple authorizations can apply to one product. So if you've got an end product like my laptop, which is Wi-Fi and Bluetooth, then there would be a certification for the Wi-Fi, certification for the Bluetooth, and then the laptop itself would probably have an SDOC for the electronics. So on the topic of radio modular approvals, the whole point of it was to reduce the certification effort. The module manufacturer can handle the certification so that when it gets installed into an end device, the end product manufacturer doesn't need to go through the certification stage. Now, when that rule was first written, it was generally acknowledged that there would be a hope that some of the test results, even from the module, might be applicable in the end product. But that doesn't mean that it would guarantee the end product would always comply, and it's still the installer's responsibility for checking. But the modular approval concept is that the module can then be used in any host. And so what happens now, this week, the webinar is all about putting that module into a product and what we do. Well, as I've kind of skirted around the subject, we're getting down to it now. If you've got a certified module for the USA and Canada, you put it into an end product, then there's no need to certify that host because the transmitter is already certified. In fact, I'd go a step forward and say, not only is it not necessary to certify the host, but you can't just say, well, my module's certified, I'm going to install it, and therefore, actually, I'd like a certification on the end thing based on the fact that my module was certified. You could forget that the module was certified, completely retest it, and certify the end product. So it is possible to certify the end product and forget the modular approval, but that involves more testing, and it involves a full certification procedure. You can't just say, my module's certified, and I'd like the certification to transfer to the host. That wouldn't be okay. So if you're installing a certified module, then the end product isn't certified. The end product doesn't have the FCC ID or a Canadian certification number. Instead, those certification numbers still relate to the module. So the end product is labeled with contains FCC ID and then the FCC ID number of the module, or contains IC and the Canadian certification number of the module. And if you were to go onto the FCC or Canadian website, and if you've got a product and it says contains and then the ID number, if you go to the FCC or Canadian websites and type in that number, you'll see the module. You won't see the end product because the certification is on the module. So those numbers relate to the module and not the host. Right, I've got my crayons out now and I'm going to do some drawing. So here's an electronic piece of equipment. It's a box. It's got a cool lightning strike painted on it. It's a piece of electronics. And that logo specifically means that the manufacturer, that FCC logo, means the manufacturer has done an SDOC on this product because it's an electronic device. They've tested it to Part 15B and they've done an SDOC. Now let's imagine that that product has also got radio communication in it. So they've certified it. So it's got FCC ID on the product because it's a transmitter, and it's got an FCC SDOC logo for the electronics. Well, now what happens then if instead of certifying their end product, they've bought in a certified radio module? So here's our radio module. It's a transceiver in this example, and you can see the FCC ID mod 1 on my module. So when they install that module into that end product, the product doesn't have its own FCC ID. Instead, it states contains FCC ID mod 1. Interestingly, if the enclosure of the host was somehow transparent or clear, or it had a window and you could actually see the FCC ID on the module, it wouldn't be necessary to have the contains on the outside. But in most cases, you can't see the module when it's installed, and so you have contains FCC ID mod 1 in this example on the outside of your host. And if you've got multiple modules in there, you can have contains FCC ID multiple times. There's no limit to the number. And in fact, if the product has got its own radio as well, then it could also have its own certification, but just for that transmitter part. And then it could have the contains FCC ID or IC number for the modules that are inside it. So some of the labels can get pretty busy. It could have, the product could have its own certification and reference different modules. So what about a kitchen appliance here? You can see here a fantastic drawing of my washing machine. So it doesn't have any logos or labels on it because it's just a kitchen appliance. And the electronics of a kitchen appliance are exempt from authorization. Unless, of course, maybe it's got a radio receiver in it. And if that receiver is from 30 to 960 megahertz, then the manufacturer would need to do an SDOC on that radio receiver. And if it had a transmitter in it, then the washing machine would need a certification. So in this example, the washing machine is certified because it's got some radio communication. Maybe it's got a cellular module in it so that you can start your washing from a phone app. Well, again, same concept as before. If it's got a radio module and the radio module is the only radio communication in it, then it wouldn't have the FCC logo for SDOC because the electronics are exempt from authorization, but the module might need certification. So when I said that the electronics are exempt, it doesn't mean the whole washing machine is exempt. It means the digital electronics part would be exempt because it's an appliance. And if you put a module in it, then this module requires the certification, which it has, and it has the contains FCC ID on it, but still the SDOC would be an exempt because the digital electronics are in an appliance. If it's a cellular module, for example, which also uses LTE bands in the 30 to 960 megahertz, then the whole washing machine would require a test and authorization as a receiver. And then you might see the FCC SDOC logo on it. Hopefully that makes sense. Now here's my fantastic drawing of a car dashboard with infotainment system. And again, electronics for vehicles exempt from authorization. Well, this one's got Bluetooth or Wi-Fi in it. So in this case, the transmitter part is certified, but the electronics are still exempt. In this one, the dashboard doesn't have a transmitter, but it does have a receiver in it, and so it's had an SDOC. And on this one here, you can see that they've got a transmitter in it, and it contains FCC ID because it's got a radio module installed in the dashboard. And if the module happens to have a receiver tuning between 30 and 960 megahertz, then of course the dashboard will require the SDOC procedure. So with regard to radio module installation, then the certification has already been handled by the module, and any changes to the module would need to be handled in the certification of the module. Well, the certification of the module isn't owned by the installer, it's owned by the module manufacturer. In FCC terms, we would say the grantee. So if you want to make a change, like a different antenna or software changes, you may need to go and work with the module manufacturer to update the certification of the module, because the installer can't do that. Even if you say, well, I made a minor change to the module, I've done some testing and I've confirmed it didn't affect anything, or the antenna was the same type, so it's all a class 1 permissive change because I used the same type antenna but a lower gain, and I've looked up that's kind of class 1. Well, nobody can apply any type of permissive change except the module manufacturer or the grantee or whoever owns the certification. And so any change needs to be communicated through the module manufacturer. So I mentioned their permissive changes, and we won't go into them in too detail. Hopefully you've got a concept of what they are. If you've got a transmitter that's certified, you make changes, for example, to the antenna or the software or the construction or any of the hardware which isn't part of the transmitter, then it can be handled by a permissive change. Obviously, if you change the transmitter hardware, that requires a new certification, but it requires a change by the grantee. So again, if you're changing those things on a module that you've purchased, then you need to communicate and work with the module manufacturer to get that done. Unless you do a change in ID process, or multiple listing as Canada call it, to put your own certification number on the module. Again, it would be on the module, not on the host. And that's the permissive change procedure is all mentioned here. And we will talk again about this change in ID concept. If you've got a limited modular approval, perhaps because it didn't have a shield or a voltage regulator, it will of course have been tested in the host. And if you want to put it now into a new type of host, then it does require a permissive change. So radio module installation then, as I've mentioned, the transmitter is certified, but what about the end product? Well, the end product does still need its own authorization. For example, maybe it's SDOC as an electronic device. And this final radio product, let's call it, which is the host with the module in it, it must meet the test requirements for that product. Quick reminder then of what the assessment or testing requirements for Canada and the USA are: RF exposure safety, EMC emissions, and radio transmitter performance, and they must all be tested to the correct approved or published standards or test methods. So the host product, or the final radio product, must comply with its own requirements. So if you've got a host product, let's say it's some electronic device, probably it's going to have an SDOC on it. It does need to meet all those things with the module installed. Anybody who's ever done any EMC testing, EMC emissions, will know if you change anything at all, you may have affected the EMC emissions. You can't say, well, I've got a product here, I've put a module in it, but I don't expect it will affect the EMC emissions. Well, two things. Firstly, from an engineering point of view, that's nonsense. And secondly, from an FCC and Canada point of view, that's simply not permitted. If you've watched my webinar on hardware variations, you'll know that for the USA and Canada, you have to test every hardware variation. And so putting a module into something is, of course, a pretty significant hardware variation. If there are other transmitters, so if your host product already has a transmitter in it, and then you've put a certified module into it, Well, then, of course, you've got to test what are the consequences of putting those together. And also, the radio module that you've installed is now part of the host for its testing. What do I mean by that? Well, let's say you're doing part 15, subpart B, EMC emissions on an unintentional radiator for your SDOC testing. And you call up the lab and say, I need to do spurious emissions testing. And they ask you, what's the highest clock frequency in your product? And the highest clock frequency in your product is, let's say, 100 megahertz. So therefore, you're going to do your spurious emissions up to 2 gigahertz in this example. And then you say, well, by the way, I've also got a Bluetooth module in it, but it's a pre-approved module. Well, the module may be pre-approved and already certified, but it does have a 2.4 gigahertz frequency generated within it. So that has to be taken into consideration when calculating this. So even your unintentional radiator part 15B emissions would now be done up to 12.5 gigahertz in this example. So when testing or approving your final radio equipment, it must meet all of the requirements, and it's the end product's manufacturer to ensure that the product is authorized and that the transmitter module certification is correctly in place and that the combination of the two of them could pass those tests. And the FCC have given us lots of really cool examples of products that did not pass when they come together. And it's anything from really quite complicated computer systems to a simple theatre light that had a radio module put into it, and the back metallic reflective thing of the theatre light with the module in it acted like a huge dish antenna and radiated out all those harmonics and the transmitter signal way over the limit. So not a modification to the module, and not been put into a complex product, simply put into a theatre light, but the combination created a non-compliant product, the light with the module in it, which of course is not okay. So this is time for some engineering judgment then. When the module manufacturer did their test and certification of the module, they had to fully test it, every mode, every modulation, every bandwidth, 3 channels per frequency band, everything. And when you install it into your end product for your SDOC assessment or certification of your main product, like the electronics of your product, you need to fully test that because that's how that works. But what about the testing that's already been done on the module? What about the transmitter mode tests? How many of those do you need to retest on the end product? Well, the FCC rules and Canadian standards are usually so clear on how much testing must be done or what a procedure is, but this is one of the few cases where it's left to some engineering judgment of the installer. Partial transmitter testing may be okay, but the manufacturer of the end product must be able to justify and explain. If somebody was to ask you, how much testing did you do? Where's your evidence of compliance? You need to be able to say, here are the reasons that I sold this product. So when you've got a radio module which fully tested on a little test jig, fully passed when it was tested on a little test jig or the end of a cable, and then your host product passes the EMC emissions with it installed, but all those transmitter tests, the installer needs to consider which of those tests could you have affected by your installation. Now, you could do a lot of research. You could ask somebody to help you with a test plan, or you could perform your own test plan, not just based on guesses. Don't just sit around a meeting room throwing darts at a board and seeing what number it lands on. You could have a technical justification plan, but often performing the testing is quicker and, of course, much more risk-free. But we will look at some test reduction here. So you might say, well, where is it written exactly which tests I must do? And actually, there isn't a clear list of testing. This has actually been something we've been discussing with the FCC a lot lately. The TCB Council has a modular committee, and we've been discussing this thing of when a transmitter module is installed into the end product, how much of the transmitter mode testing must be repeated? And there's a few of us that work for test labs. I'll be honest, you say, look, life's going to be easiest for us if there's just a clear list, you know, like you've got to do these tests and you don't have to do those tests. That way we're all quoting the same things and manufacturers know exactly what they're doing. And that way the manufacturer could just look at the list and go, oh, okay, I see that I have to do this. But actually there was a lot of pushback against that. And the real reason for that does make sense, because there's two parts. Well, what if the list of tests that you had to do was quite long? And what if the product that the module was installed into was really similar to the test jig? We might be mandating that the module installer repeats a lot of testing that's perhaps unnecessary. But you could also look at it the other way. What if the list of test cases was short? What if it said, oh, you only need to repeat the spurious emissions tests? And so the installer says, great, I've seen a written list. I only need to repeat the emissions tests, so I'll do that. And then maybe their installation affects the signal bandwidth or the output power. And so suddenly somebody, the FCC, for example, has said, you don't need to do these tests. And you could be selling a non-compliant device based on that recommendation. So there's no list of tests that you must do, but there also isn't a list of tests that you don't have to do. So the decision as it stands so far looks like that it will still be left up to engineering judgment of the installer to ensure that you've covered everything, to ensure that the end product would comply if tested. So there isn't one definitive list of test cases. The manufacturer takes ownership. Now you could ask a test lab for some advice. Test labs, I would say nobody can guess the results of a test without the test being done. If somebody claims to be able to guess, then you got to look at their motives. If somebody says, like, I'm an EMC or radio expert, I'll tell you that if you do this and this and this, it will pass and the result will be this. Be very careful of that. But also a test lab has a very clear set of roles and responsibilities. And the test lab's role and responsibility is to perform tests and report what the results are. Nothing in the test lab's roles and responsibilities, especially for the FCC and Canada accredited labs, that says that they're allowed to make guesses about tests they haven't performed. If you start putting multiple radios into a device, the whole topic becomes even more exciting and complicated. The FCC rules do state that for the end product, it must comply whilst all transmitters are active. Now, if you've got a multiple transmitter device and you're getting it certified, then you don't always need to provide that evidence to the TCB. You test and certify each transmitter independently, and then as the radio manufacturer, you're responsible for the fact that the end product would comply with all transmitters on. And in the same, if you install multiple modules, doesn't mean you necessarily have to go and submit the results to people, but it does mean that you need to have the confidence that with all those transmitters on, it would comply. So that does just increase the amount of assessment you need to do. Also, your end product must meet the output power limits. So, for example, if you've got a 2.4 gig Wi-Fi and a 2.4 gig Bluetooth and a 2.4 gig Zigbee, and you put them all into one product, and they're all 3 certified modules, well, they would have passed the 2.4 gig power test independently, but if they can all transmit at the same time, you need to add them all together and check that your end product isn't exceeding the output power limit for that frequency band. And RF exposure. The RF exposure assessment will have been done by the module manufacturer, and an installer needs to check if that's still appropriate for their product. And if you've got multiple transmitters, you need to start combining or summing the power levels, or if they're operating in different frequency bands, then you're looking at their kind of pass-fail ratio and adding all those together. So let's have a quick look then at the types of testing you would have to do when you install a module into an end product. Well, as I've mentioned, your EMC emissions of your electronics, such as for your SDOC, is always going to be performed on the end product with the module installed. So for Part 15, Subpart B, or the ICES standards of Canada, the transmitter doesn't need to be transmitting, and in fact, it shouldn't be transmitting. The module should be powered, but should be in a non-transmit state to ensure that the end product complies with that piece of hardware in it. The emissions are therefore tested on the host product with the module installed, and because the end product authorization, such as an SDOC, is all based on mandatory testing. But as I said before, be aware that the frequency range of the test may have changed because you put the module in your product. So now the radio transmitter performance then. This is a case where you can start to save some time and save some effort at the lab. So the module has already been fully tested for a whole load of conducted antenna port tests, most likely, and certainly some radiated transmitter tests. And then when you install it in the end product, it's a general recommendation, and everybody does this, that the radiated transmitter test cases are repeated at the end product level. Because if you've got a radio module transmitter and you put it into an end product, who knows what you've done to the radiated emissions from that module, similar to what we said before about the EMC emissions. But the conducted antenna port test cases, well, the installer or the integrator of the module might choose to accept some of those conducted test cases if they have confidence that they haven't affected any of those results. So it's not just a blind case of going, yeah, we don't have to repeat the conducted test cases. You should look at them and ask yourself and document whether you think you've affected them or not. RF exposure assessed at the final product level. If the radio module was assessed for a mobile device more than 20 centimeters from a person, and that's the kind of device you've installed it into, then you're just going to take that calculation from the module. If the module is portable through the fact that it's such low power that it's got a SAR test exemption, then again, you're going to carry that exemption over and you don't need to do anything. It's only in the case where a test is needed, such as a SAR test on the end product or an MPE test, and then the testing would be performed on the end product, because things like SAR and MPE are really product specific, they're enclosure or construction specific. And of course, don't forget receivers. If you've put a cellular module into your product, don't forget that your end product will require a test and authorization as a receiver. So the installation instructions that you got with your module should have been very clear on exactly the antenna type and antenna path layout. If you want to change any of those things, then effectively you are changing the antenna type. And only the module manufacturer or the module grantee can decide if your antenna is the same type as the one they certified or not. So you're going to end up contacting them if you want a different antenna solution. The FCC have often said that people call them up and say, I've installed a module, what do I do? And they really don't appreciate that, because it highlights to them that the module manufacturer didn't give enough information. So as an installer, if you contact the FCC with that kind of question, you're really going to get the module manufacturer into some trouble there. And it's a reminder that testing and approvals are really different topics. So it might be the case, don't forget, you're going to have to repeat your testing on the end installation. But also, if the module antenna type is different or the construction of it is different, then the transmitter certification might need an update. So you might say, well, my antenna type is different, but my results look the same. Well, okay, the testing is good, that's done, but you still need to update the certification. Now, I mentioned a change in ID. Now, there is such a thing as if you want to take over the legal responsibility of a transmitter, can only be done through with the permission of the original manufacturer, so the module manufacturer, for example. But you can, as the installer, do an FCC change in ID or in a Canadian multiple listing to put your own certification number on that product, onto that module. It's purely optional. It's never a mandatory step, but it is recommended in some cases. If you do that, if you do the change in ID and multiple listing to put your number on it, then you can start changing antennas, putting it in with other modules, things like that. And you can start making changes to the certification without having to go back to the module manufacturer over and over again. It's a pretty simple paperwork project, actually, the change in ID. The only thing I would recommend is be careful, because whereas the FCC has the sort of grandfathering, once it's certified, whereas Canadian approvals are much more like the European approach, where you always have to keep up to date with the latest standard. So if you're going to take over somebody else's transmitter certification, make sure you understand all of your responsibilities for Canada. So if you've got a mobile module, this is a RF exposure condition at more than 20 centimeters from the body, and you put it into a portable host, that requires a change, because the RF exposure condition is a certified condition type. If you take a mobile module and put it into a portable host, a change is needed. And in most cases, this can be handled through a Class 2 permissive change. However, if the host product is small, portable, wearable, Canada specifically states if the product is less than 20 centimeters or if it's got some other transmitter in it, whereas the FCC just says small, portable and wearable. If that's the case, then actually modular approval can't be used. You can't put the contains and the certification number, and you can't continue with the certification of the module. If you're putting a mobile module into a small, portable, wearable host like a phone or a watch, it requires end product certification. So a quick comment about market surveillance in North America. If market surveillance finds a non-compliant device, if they find a non-compliant radio module, then they're going to go after the module manufacturer. If they find a non-compliant end product and the FCC ID and the certification number still point back to the module, then the FCC in Canada, they're going to go after both groups. They're going to go after the module manufacturer and the end product installer. Now, if it turns out when the investigations are done that the module passed on its own and it failed when it was inside the host, then the module manufacturer is fine. They're off the hook now, and it's the end product manufacturer who's in trouble because they've been selling a non-compliant product. If the investigation finds that actually the module manufacturer lost a bit of quality control and they've been selling a non-compliant module and it continues to be non-compliant when it's installed in the host, then the module manufacturer is in trouble, even though it's the end product that failed, and also the end product manufacturer is also in trouble for not noticing that. So the end product manufacturer is always going to be responsible. So the installer or the end product manufacturer may need to work with the module manufacturer, for example, to sort of handle changes. So I would always recommend, when you're shopping around for a radio module, don't just go on cost. Go for a module manufacturer that you get good support and they understand your requirements and they're happy to work with you. You might need their support if there's a permissive change, like you're going to change the antenna, or if you're asking them to do a change in ID so that you can put your certification number onto their module. Also, when you install the module into your end product and you need to do that testing of the transmitter modes of your end product, well, you might have to stop the transmitter hopping, or you might have to set it to maximum power on certain channels. And so working with a module manufacturer who's going to help you do that is really going to be useful. We come up against a lot of installers who say, well, I've installed a module. I understand I need to test my end product, but I don't know how to control the module. Now, as an installer, of course, you do have the choice to say, therefore, I'm just going to test it in its normal mode, how it is working. But if you really want to have some confidence, you might want to be able to set it to bottom, middle, and top channels, maximum transmitter power, in which case you're going to need the support of the module manufacturer. So again, pick one who's prepared to work with you. And you want to also work with a module manufacturer whereby if they make a change to their module, they're telling you about it. Because if you've tested your end product based on the installation of the module, and then they start making changes to their module, it could affect your own testing, and you might need to know that. So some common mistakes then when installing radio modules in North America: having good connection to the module manufacturer. or not having good connection, should I say, is a common mistake. Thinking that it's just plug and play, thinking, well, it's a certified module, I'm going to plug it in and now I don't need to do anything, where hopefully you've realized that is not the case. Not testing the final product as a final radio product and thinking it's simple. I've got a slide on that topic in a little while. Forgetting to take legal responsibility for every aspect of the product, including the radio in it, but also this is a reminder for the module manufacturer that you do still remain legally responsible for your module when it's installed in the host. Often the wrong company can be asked and does take the wrong role. Sometimes a manufacturer will say to a test lab, can you tell me which tests I should do when I install the module into my host? Now, of course, the test lab can offer some advice and some guidance and help the manufacturer to determine that list, but ultimately it's all about the module manufacturer's decision, and the lab shouldn't be pretending that they could somehow guess results of non-tested modes. Forgetting that the receiver could require authorization, and of course, just reading poor information on this topic. Okay, let's fly across the Atlantic to the European Union and a quick mention to Great Britain as well. So in the EU, we've got the Radio Equipment Directive, and it's all about a declaration of conformity on the end product. And this applies to anything with any kind of radio communication or radio determination in it. Transmitters, receivers, or transceivers. So it's all about the end product, and it doesn't matter whether you made that product or you put a radio module into it. If the radio module is permanently installed into the product before the product is placed on the market, then the product is radio, and it's in scope of the Radio Equipment Directive. The end product has a declaration of conformity which covers all aspects of the device and everything in it, including the module, and all responsibility is on the manufacturer, basically the person whose name or the company whose name is on that end product. So what do you do then if you take your CE marked radio module and you squeeze it into some other product? Well, if you've got a CE marked radio module and it's presumably been CE marked to the Radio Equipment Directive, and you put it into some other product, maybe that other product would have had a CE mark anyhow, well, you've now got a CE marked radio equipment. Of course, it's not CE marked until you as the installer have decided it is. Simply CE marking the module and CE marking the host and putting them together does not equal a CE marked end product. The end product does need to be CE marked to the Radio Equipment Directive, and that's the job for the installer. So the installer of the module, the manufacturer of the new product is fully responsible. The product must be fully assessed. Now, again, just as with the FCC, it doesn't necessarily mean you fully test everything, but you need to have all the knowledge and confidence and evidence that it could pass. The installer of the radio module therefore becomes the final product manufacturer, and there's no reference to the module manufacturer. There isn't an FCC idea carry across, and so the module manufacturer is kind of out of the situation then. Now, I said to make a product in scope of the Radio Equipment Directive, the module needs to be permanently installed in the end product before the product is placed on the market. And what do I mean by that? Well, aftermarket plug-in that the user could plug in and out, that doesn't count. So my laptop here has got a USB port, and if I plug a wireless dongle into it, my laptop doesn't suddenly become a new type of radio equipment, because this is just two different products that are intended to be connected together. So if you've got an electronic device and you open the cover, plug in a USB dongle and close the cover, you don't magically have to CE mark that to the RED, as long as those two products were assessed for that environment. But if you've got a product like my laptop here, which has got modules installed in it before I bought the laptop, then it's in scope of the RED. There are a couple of exceptions. So type approved vehicles. If you put a radio into a type approved vehicle, you don't have to CE mark the car to the radio equipment directive. The radio remains legally separate to the vehicle. That's under a lot of discussion at the moment. And the other type of thing is a fixed installation. So I don't mean like a base station, that's a product. When I say fixed installation, I mean like a house or a factory or a warehouse. If you wired a wireless fire alarm system into a house, you don't CE mark your house to the RED. Instead, the radio product remains separate. And so the same concept applies with radio modules. So you've got your radio modules there. They're both CE marked. One's a they're both transceivers there. One's in transmit mode, one's in receive mode. They've both got their CE marks on them. And if you were to put a radio into that product, you remember this is an identical slide to where we had earlier. With the FCC, you've got all that exciting labeling going on. Whereas with Europe, you've simply got a CE mark on the end product, and the CE marks of the modules are effectively gone at that point. So if you've got a lot of complicated things happening, you've got one or more modules into an end product, I'd always recommend a test plan, especially if there are other types of directive involved. So for example, if you've got a medical device or a machinery device where you've got different types of standards, different types of limits for different environments. Ultimately, as the manufacturer of the end product, the one who installed the module, you're going to have to generate a risk assessment. And your risk assessment is where you decide how much testing you have to do. So you will determine the scope of your testing so that you can decide whether you have applied the harmonized standard or not. This is your assessment plan, the first document you open and the last one you close, because your whole job is to be able to look at your end product and go, I've got some results from the module manufacturer's test report, which they kindly gave me, some results which I'm going to test on my end product, and how can I justify that I've met all the appropriate standards? Even if you're planning to say, I'm not using the harmonized standards, I'm going to a notified body, the notified body is still going to want to see evidence that you would meet the standard. So the RED's assessment scope, as we know, is product safety, EMC emissions and immunity, radio transmitter performance, and some other Article 3.3 categories, such as in 2025, we will have cybersecurity. And you will assess your end product with standards, ideally harmonized standards. Now, there are some useful guidance documents around. The RED CA has Technical Guidance Note 01. This is a good document. It also has TGN 31, which deals with combining multiple radios into a single product. So not specific to modules, but useful for anyone installing modules. There's an ETSI guide on putting radios into non-radio equipment. And then there's another ETSI guide on mixing types of operation and EMC assessments at the end of it. But actually, regardless of which one of these you read, they all kind of say the same thing. They all say your end product must comply. And if you think you might have changed something, you've got to go and test it. So let's have a look at what sort of tests you would do when installing a radio module into an end product. Well, product safety is always going to be performed on the end product with the module installed. Now, just as we said with the FCC, RF exposure is going to depend if you need to do a test or it's a calculation. So for example, if your output power is less than 20 milliwatts and you know that you don't have to do a SAR test, then that's a calculation that could just carry on from the module to the host. But if you need to do a test, then that's going to be done at the final level. Product safety under the RED doesn't just cover electrical safety, it's any aspect. So you need to also ask yourself, for example, if you've made some sort of robotic device or kitchen appliance or whatever, does my product suddenly have a new safety concern because I've made it radio enabled? For example, you might be able to control it while you're not in the room. EMC assessments, well, the EMC assessment is always performed on the end product with the module installed. So you're not carrying any EMC test results over from the module to the end product, because EMC is really an assessment of the construction and how the end product works. And if you've taken a radio module and put it into another product, then those are the two things that you have definitely changed. The emissions would be tested on the end product, but actually the emissions are also covered under Article 3.2, or would typically be covered under Article 3.2. So EMC performance of a radio product is typically all about the immunity. And so when you're doing your EMC immunity testing, you are including the assessment of the radio. Now, again, as we said with the FCC, the radio performance is where you could start to save some time. The radiated test cases, again, there's nothing that says you have to do this, but everybody tests the radiated transmitter test cases in the final host. Why do we all do that? Well, it's pretty obvious. A radio module is going to transmit one way, and when you put it into a host, it's all going to be different. And you can't predict how it's going to be until you test it. However, those conducted antenna port test cases, if you can be sure that you haven't changed them, then maybe you don't need to repeat those. So, for example, the bandwidth of the signal, or the duty cycle, or how fast it's hopping, or how many channels it hops on, you might be able to realize that you haven't changed any of those things, and they're conducted antenna port cases, so they're not affected by the installation. So you might just take those from the radio module's test report. But you do have to consider which tests are affected by the installation. And these other categories, well, at the moment, the only real ones to think about are the emergency calling of a mobile phone, and mobile phones don't typically use radio modules. But over the coming few years, cybersecurity will become a big thing. Now, this needs to be assessed at the end product level, but we do acknowledge that some radio modules may have had some assessment done on them, and so therefore the installer will be looking at what the module manufacturer has done and how that can carry over. It's kind of impossible to predict that until we know the cybersecurity tests for modules or radios. But I'm sure we'll find that out in the next couple of years. And it's also important to remember that these aspects, like cybersecurity, these are product specific, not technology specific. So you can't say, does a Bluetooth module need cybersecurity? Instead, you'd say, this is the end product. This has a cybersecurity requirement to it. So again, exactly the same slide as with the FCC. There isn't a definitive list of tests you must do, and there isn't a list of tests you don't do. Anything construction related, like safety, EMC, and radiated test cases are always done on the end product level. For other things, they could be abbreviated. But even those tests, we'll have a slide in a moment where it says you may not have to test them all. So with regard to the assessment of the final radio then, any acceptance of test data from the module is at the decision of the installer, of course. Everything should be included in the module, in the end product manufacturer's risk assessment. And the manufacturer of the end product is the one signing the declaration of conformity, which covers everything, including the module. If there are any changes to the module, those need to be assessed. So it's not like with the FCC or Canada, where you would go back to the module manufacturer and say, I've changed your antenna, you need to update your certification. There is no certification. So if you change the module's antenna, of course, you're retesting it, and that's just all part of your end product. But similarly, if they change their module that you're buying, then you need to somehow keep an eye on that, because that could affect the testing you've done. And they may be under no legal obligation to tell you that they've made that change. And so a good relationship with the manufacturer is recommended. There are no permissive changes in Europe, but there are versions of the standard. So, of course, be aware if the module manufacturer sold the module to you under one harmonized standard, and then the standards change before you sell your end product, then you could be selling your end product under a different harmonized radio standard to the one you bought the module under. So yeah, keep up to date with changing standards. And if a notified body is involved with an EU type examination certificate, notified bodies are mandatory if the radio standard isn't harmonized, and in the future that will be the same for cyber. If the module used a non-harmonized standard, or just wanted to get a notified body certificate, then that's fine. But certificates are not transferable from a module to an end product because they're completely different products. So let's say, for example, the radio technology uses a non-harmonized standard for radio. So the module manufacturer must get a certificate, and then you install the module. You want to sell your end product. The harmonized standard is, the standard is still not harmonized, so you need to get your own type examination certificate because it's all about the end product. This becomes even more tricky when combining multiple radio modules into a device because you've got to have some confidence and evidence that the end product complies. And the module will have been tested nice sitting alone in a nice quiet anechoic chamber, and now suddenly it's in an electrically and thermally noisy environment like a host product, maybe with other radios involved. It can affect the transmitter and receiver performance test cases, and therefore there would be fewer tests that you could trust from the module's test reports. Interference between transmitters in a product, or between the transmitter and a receiver, or between the host and the radio module can all affect the performance of the end product. Remember, the goal isn't just to be able to say, I passed the tests. The goal is to sell a good product. And these regulatory tests are there to help you determine if your product is a good one or not. And so how do you know if you're selling a good product if you don't know if it meets the standards or not? If you know it could meet it, then you know it's a good product. But if you don't know, then you don't know if it's a good product or not. It is acknowledged that the European compliance approach heavily relies on manufacturer integrity, and of course this carries over onto the module installation world. With regard to market surveillance in the EU, if market surveillance finds a non-compliant radio module, then they're going to go after the module manufacturer. If they find a non-compliant final product, they're going to go after the final product manufacturer. So some common mistakes then when selling to the EU. Again, make sure you've got a good relationship with the module manufacturer. In the USA, for the FCC testing, you can go onto the FCC's website and find the module manufacturer's test reports. But for Europe and the European test standards, there is no such database. And so you're going to be asking the module manufacturer for their test reports. I still have some people say, oh, my product isn't in scope of the RED. I use the EMC directive and the low voltage directive because it's not my radio. I just installed somebody else's module. Well, if you install somebody else's module, then you make a radio product and you're not in scope of the low voltage directive or the EMC directive. You're now in scope of the RED. People, of course, not testing the final product correctly and somehow thinking that CE plus CE is CE, which is, of course, not the case. Understanding is an important thing to understand that when you buy a module, you take over responsibility of the compliance of that module and any changes that happen to it. It's important to remember everybody's role. If a test lab has said, don't test that, you don't need to test that, it might be really, really good advice from the test lab. But remember, legally, it's your responsibility to decide whether you accept that advice or not. Thinking it's simple is a common mistake, and reading all the misinformation on this topic. Okay, so some general comments now about testing for the USA, Canada, and Europe. Manufacturers, I've noticed, take real differing approaches to this. Now, some of them would say, I really, really want to reduce my time at the lab. So they'll say, I've installed one radio module into my end product, or maybe even two modules, but I don't want to spend more time than is necessary at the lab. So I want to get a consultant or an expert, or maybe we've already got an expert in-house, or maybe we'll call up Michael at Element or somebody else. We've got an advisory services team, and we'll get them to go through all the test reports from the modules and all the construction of the end product and come up with a test plan which demonstrates the minimum amount of testing. And we could do some testing, and if the results look good, we know that we've done enough, and if the results don't look good, we'll get back in the lab and we'll do a bit more. Other manufacturers would say, well, we don't have that expertise and we just need to get to market as quickly as possible. We can't be in the lab and then out and then in and then out. So let's just test it and then we're done. And then we don't have to worry about that. We get to market quicker in most cases, and we're just done at that point. We haven't had to pay anybody for a test plan. Time to market is the critical thing. I think most compliance managers get told by their boss, please try to reduce the amount of money you spend at the test lab. But probably what your boss means is try to reduce the amount of money you spend at the test lab, but whatever you do, do not let our time to market slip. Ultimately, you need to have confidence that your end product is compliant, because why would you do that? Because we've said a compliant product is a good quality product that you can legally sell and it should perform well. If it is non-compliant, not only are there legal implications, but probably it was not going to perform as well. So when you're testing a transmitter or receiver, the module itself will have been tested. And then when you install it, as I've said, everybody repeats the transmitter spurious emissions. Well, why does everyone repeat transmitter spurious emissions? Because it's a physical change. You've got a module, which is typically a small thing. Radio signals radiate out of a product, and the size and the construction of the product is a really critical factor. So when you install that module into some other product, you've completely changed the physical shape, the physical construction, and therefore you've changed the radiated performance of that product. And until anybody's ever done that test, nobody knows whether it's going to pass or fail. These are unknown consequences, and so no matter how long you sit around in your meeting room trying to guess will it pass or fail, you won't really ever know unless you test. So let's say you do an emissions test of a radio module. Okay, then my beautiful plot there. So I've got my radio module and there's my spurious emissions. So you've got your big transmit signal at the front there, and then you've got your little harmonic signals coming off of it. They probably don't radiate that big because it's just a little module, doesn't have much in the way of cables, and there's not much happening with it. You then put that radio module into another product. There's cables, there's enclosures, there's slots, there's the whole enclosure of the product might re-radiate the signals, and suddenly those emissions were bound to change. They'll most likely go up, or they'll go down, or they'll stay similar, but we don't know. And you can't simply ask, what are the emissions of this module like when they're in a host, because it varies by host to host. Even just changing the type of enclosure slots will change the size of those, will change the frequency of the signals that come out. So if you were looking closely at the last couple of slides, you'll have seen that, for example, here a module might have very low emissions. You put it into a host and the emissions might look the same sort of shape profile but go up, or they might completely change the profile. And if it's like narrow slots, the high frequency signals might go up and the low frequency signals might come down. And suddenly, if you start putting a second module in there as well, it all gets crazy, because you get these things known as intermodulation products, where two transmitters cause emissions that was never actually there for either of them individually. So how much testing do I need to do then when I'm installing these modules? I've said that everybody does the emissions test, and sure enough, it's pretty rare that anybody chooses not to do the transmitter radiated emissions test these days. Well, how do you know how much testing is needed? And the answer is enough that you have confidence that it will pass the tests. Now, it might just be quickest to test them all, especially if your lab has quite tight booking slots, and then it's going to be a long time till you can book another one. It might be easiest to just say, let's book it in and test it all. But you might have time and knowledge to plan for some test reduction. We could help you for this, and in fact I did spend quite a lot of my time in the past making test plans for people when they install radio modules. So for example, you've got a radio module here and there's its emissions, and you might say, well, actually look, the emissions from my module start to taper off after about the 5th harmonic. The FCC rules say to test up to the 10th harmonic. I could do that, But actually, look, by the time we get to the 5th or 6th, they've almost gone. And you put it in your host and you go, right, well, actually, yeah, it's still the same. It's gone up, but still the emissions are dropping off after the sort of 5th or 6th harmonic. It's a decision you can make. You can say, I've got enough evidence here to stop testing after the 6th harmonic or the 5th harmonic or the 7th, however makes sense. But it's important to know your product, because if you were one of the ones where the higher frequency ones have gone up, well, then suddenly you'd say, actually, no, it's not okay for us to stop at the 5th harmonic. There's guidance that says you could stop at the 5th harmonic, and you can if it makes sense. But it's not just, hey, I saw this thing. It says only test up to the 5th harmonic. So you need to know your product, you need to know how it works and justify your decisions. And it might be that you're not waiting till the final step to do that testing. It might be that you're doing your development testing, your R&D testing as you're going along, such that by the time you get to your end product testing, you can say, I know that we don't see anything after the 6th harmonic, for example. So what about all those transmitter test modes then? If anybody's got any Wi-Fi out there, some of those test reports are in the thousands of pages now. You're looking at 3 channels per band, every modulation type, every bandwidth option, and checking different data rates. Pages and pages and pages of transmitter test modes. And they've all been tested by the module manufacturer. And when you install the module, your job is to check that that end product would pass. You could go and test everything, but there is definitely scope there for test reduction. I've got my crayons out again. So here's our frequency band, right? This is the transmit band of our device. And let's say we've picked a modulation type and we're going to test on the bottom channel, the middle channel, and the top channel across our frequency band of operation. And when we do our spurious emissions test, that's not grass, that is actually your harmonic emissions from your transmitter on those 3 channels. And the module manufacturer will have tested those all the way up to the 10th harmonic, because they had to do that for their certification. But now you've got a different type of modulation. That one had to be tested at 3 channels all the way up to the 10th harmonic. And then maybe another one. And then maybe another one. So for example, if you've got 802.11b and G and N, or N and A and AC and all the different bandwidth types, or you've got different types of LTE signal, 16 QAM, 64 QAM, 256 QAM, all of these different settings will have all been tested at great length by the module manufacturer. And all those results should be available to you. So you should be able to look at the module's test report and go, right, well, I can see that they didn't know their module, so they fully tested it and they had to test it. But now it's been tested, I can see which channels from the module had the highest output power, and I can see which modulation types and which channels gave the worst case emissions. So I could start by testing those ones. So for example, if I knew which ones had the highest power, and I started focusing just on that one, then I could say it does all these modes and all these different modulations, but I'm going to test this one because this one was the worst one. And if this one passes by miles, I have every confidence that all the others would pass, most likely. But it's not always that simple. Results from the module don't perfectly correlate to results from the end product, because different bandwidths of signals can behave slightly differently. So let's say, for example, you picked a modulation type and a bandwidth type that had the highest power or the worst case emissions, and you checked that one in the host. Let's say it wasn't passing perfectly. You could say, right, well, actually, I've got bottom, middle, and top channel on that worst one, and I've also checked the middle channel on 1 or 2 others, until you reach a point where you go, I know I've done enough now. I've got to a point now where anything new I test, the results are just coming in better and better and better. I've tested the highest power type, or I've tested the worst case emissions, and I know it was worse because it was from the modules test report, and I was close to the limit, so I checked it, and I've confirmed it really is the worst, because those other ones, they were better on the module and they're better in my host, so I'm going to stop now. So you haven't guessed, but you've definitely got some test reduction, and you've definitely got evidence for why you did that. You may need to modify your testing as you go along, and this is what I said about having flexible access to the test lab, or performing this as part of your development testing whilst you're developing the product. Ultimately, when you've got your test results at the end, it's not just a case of saying to the lab, have I done enough? You, as a manufacturer, and you can ask the lab to help you answer this question, but you need to get to a point where you can look at the results you've got and say to yourself, do I have enough evidence from this testing that I did to guarantee that it would pass if I tested all of this? If the answer is yes, I have enough evidence, then you're done. You don't need to carry on. If your answer is, well, no, I've got no idea, then you haven't done enough yet. So again, radio modules, they were tested standalone on a test jig, but what about the end host environment? The Radio Equipment Directive risk assessment of the end product that the installer has to write is where you identify which tests you need to do. So let's say, for example, you've measured a simple transmitter, mask and output power test at room temperature, and the module was tested over a range of temperatures, or maybe it wasn't. Well, if you do enough radio testing, you'll learn that when a product gets hot, the power might come down, but also the sides of the signal might go up and it might get a bit messy. And when the product gets cold, the output power can increase. So if you do transmitter testing over temperature, you'll probably find that the highest power is at the low temperature. And if the module was tested over a narrow temperature range, but you're planning to sell your product into a vehicle that will be in Greece in summer and Finland in winter, well, then you might want to ask yourself, was my transmitter testing at temperature sufficient for my end product? And also, what about your output power? You may not have changed the power, it's just a conducted output power and you've not changed it at all. But in the same way as I gave the example of the theatre light, if you think that the enclosure of your product is radiating your signal such that the end EIRP of your end product could fail, then that's something you need to check. What about receiver testing for Europe then? This is a bit of an elephant in the room situation where nobody likes to talk about it. It's a conducted antenna port test in most cases. People say, well, I didn't touch the receiver, I don't want to retest it. I don't want to retest it because it's not a very easy test in all cases. But you've got to remember that the radio module had its receiver tested in a nice, quiet, peaceful environment of a semi-anechoic chamber or a test bench where everything was absolutely fine. And you're using those results to justify whether that receiver is still going to work okay when it's in an electrically and thermally noisy environment, like inside a host with other electronics around and maybe even other radios. So a quick takeaway on radio modules then. Authorized modules are a great thing. The final product authorization must be in place. The final product must meet the requirements and the final company takes responsibility. Another couple of comments about that testing you should do, the transmitter testing, the receiver testing, the intermodulation testing if you've got lots of radios. It reminds me a little bit of when little children play hide and seek and they kind of think that if they've got their eyes shut and they can't see you, then you can't see them. People sometimes say to me, do I have to do this test? If I install a module into my product and I install 2 modules, do I have to check these tests? And the question back would have to be, if you don't look, how do you know? If you don't test, how do you know what the answers are? So people would say, do I have to do those tests? But how are you going to know if they pass or fail if you don't at least do some of the testing? And you've got to again ask yourself, what's my end goal here? If my end goal is just to cheat and get a product and I don't care if it works correctly and I don't care if it's going to have problems in the field, then do what you've got to do. But if you want to make sure that your product meets the regulatory requirements, either from a legal point of view for the sake of your person signing your DOC, but more likely from the point of view of checking your product works right, you'll never know if you don't go and look. So engage with the test lab early, do some evaluations so that by the time you get to the end stage, you already know what kind of modes you're going to have to test, how likely it is to cause a problem. Is the module and your end product going to have a problem working together? Honestly, this topic of installing modules into other products is as complex as radio compliance gets, whether you're talking about the testing requirements or the authorization requirements. It honestly does not get more complicated than this. The manufacturer's risk assessment is about as big as it's ever going to get when it involves putting modules into other products. So again, remember your objectives, understand the problem, which is getting a good performing product on the market legally that will perform well enough that other people want to buy more. The way to achieve that is to make sure it works well, and that's why the regulatory approvals are there. They're not there just to spoil your fun, they're there to make sure the products work well. Don't try and think of what's going to get me into trouble with market surveillance. Try and think what's going to make my product the best. How can I do some checks and some tests that I have really got confidence my product is a good one? And if you take that route, you'll soon realize you've done the right things. Speaking of doing the right things, here you are. You're on a webinar trying to learn. You could have just stayed, not listened to any training and just said, just going to put the module in my product and sell it. But the fact that you're here shows that you want to sell a good product, and that's a good thing. You're learning, you're understanding, you're seeking expert support and advice, and hopefully, therefore, your product will be the best it can be so that you've got some pride in your product. This is only going to become a bigger topic because, you know, when I was a little kid, your TV receiver was pretty much the only radio in the house. Now they're all over the place. My children are just at that threshold of becoming teenagers, and so the number of radio connected devices in our house is flying up. And not just the number of use cases, but just how critical the use cases are. My first job was EMC testing computers, and you know, it was easy to think, well, if it fails, what's the worst that can happen? And when you're selling a computer or a printer, it is tempting to say that. But if your product could be used in a vehicle or in a medical environment, then that question of what's the worst that can happen is suddenly a very, very different question. That's why I would definitely recommend, if you're putting a radio module into, for example, a medical device, that is definitely not the time to be saying, what's the minimum amount of testing I can do? That is definitely the time to say, what do I have to do to ensure that my product is really a good one? All right, well, I'm done. Let's go over to Danielle and see if we've got any questions. Thank you.
So we've had loads of questions, Michael. We've had at least 23, which I don't think we're going to have time to cover because we've only got about 5 minutes now. So I'm going to start with the key questions that have come up here with I'm sorry.
You're too busy sorting your audio out.
Yeah. So the first question we had, which was quite a key question, was when integrating a non-modular device, for example, a Wi-Fi router inside electrical panel, is any testing required for the FCC?
Right. So if you've got a Wi-Fi router that's not got a modular approval and you install it into some other thing, like you permanently install it inside the other thing, it can't be removed easily. You have to forget that it was ever certified and you retest completely and you recertify. If you've put it into, you won't use the word electrical panel. So if you kind of just put it into like a 19-inch rack or something like that, then it's still a separate product. It's just been slotted in. I mean, I think if it interacted badly with those other products and caused an interference, then you'd still be responsible for turning it off and getting it off the market. You wouldn't necessarily be in any particular authorization problem. You'd only have to reauthorize it if you've put it into an end product. If you've just put it on a shelf or a rack or with some other stuff, then that's okay. I think, if I've understood the question correctly.
So the second question is also related to the FCC. Is the FCC logo mandatory for a host that contains a pre-certified radio module?
Good question. No, they're completely separate topics. So when you authorize a product for the FCC, you have to look at all the individual things. You look at the electronics. Sorry, my hamster bit me, by the way. The electronics, the receivers, and each individual transmitter. So the module transmitter being certified and being installed would have the contains FCC ID. The requirement to have the SDOC on, and by the way, it's important to point out, in Europe, when we say DOC, that's an actual document that the manufacturer creates and signs to say, I've assessed my product and I think it will meet the directive. In the USA, the SDOC isn't a document, it's a process and procedure. You have to do the testing. You have to do the testing the correct way to the correct standard on that hardware variant. And at the end of that, you can say, I've followed the SDOC procedure. So if the host comes into the category of SDOC, then you could do SDOC or you could do certification. FCC allows SDOC or certification of the host, forgetting about the module, forgetting about the transmitter. Canada mandates SDOC, but they don't have a logo. So is the FCC logo mandatory? No, the logo is only applied if you have followed the SDOC procedure for something like the electronics or the receiver or something.
Okay. So there were also a few questions about the SDOC, which link into that question, I suppose. So let's suppose that we install a radio module into a host and we test it and certify it. Is there any impact if we also perform and publish the SDOC? Okay. And then the next question is also related to the SDOC, which is, does the TCB always need to make a final decision if SDOC is sufficient or additional testing is needed? I think, do they link in together at all?
No, let's definitely go for the first one. So reread the first one.
So the first one is, let's suppose, oh, I've done that one. No, let's suppose that we install a radio module into a host and we test it and certify it. Okay. Is there any impact if we also perform and publish the SDOC?
Okay, so the transmitter part of the product needs to be certified. So if it's an uncertified module that you install, you would then certify the transmitter part of the host. If you installed a pre-certified module, then you don't need to certify the transmitter section of the host. You would then, for the host itself, the electronics of the host and any receivers in it, you've got the choice, you have to test it, and then you've got the choice to do an SDOC or a certification on that. You don't publish your SDOC, it's a procedure that you go through, but you wouldn't say, so a product would often have a certification and an SDOC, but that's not two authorizations for one part of the product, it's two different parts, the transmitter and the electronics. So you wouldn't say, I'm going to certify my product and I'm going to do an SDOC on the exact same aspect of my products. That is not okay. Think of the fact that lawyers wrote the FCC rules, pick one and do one.
Okay. It is 5 o'clock now, which is the end of our question and answer session. It was a very informative presentation and webinar, so thank you again, Michael. There are a lot of outstanding questions, and what we can do is make sure that everybody receives a reply to their questions on an individual basis. If there's anything that is useful to all, we will also share that to all attendees as well in our follow-ups. Cool. So thank you for submitting questions. If you do have anything following the webinar, I did share my details in the chat, so you can email me directly or you can contact our commercial team on commercial.team@element.com. And thank you again for attending, and I hope that you enjoyed it as much as I did.
Cool, thank you. And sorry for talking over the Q&A session, but hopefully I see most of the questions were answered in the webinar, so that kind of worked out. Thank you very much.
Thanks, everyone.